Find the exact value for the expression secant 3 pi fourths. So first off, 3 pi fourths, 0, 1, 2, 3. This is 3 pi fourths. From that we need to get the reference angle. The reference angle is pi fourths. And we also need to get the quadrant. This is quadrant 2. From all students take calculus, we know that sine is the only positive one, along with its reciprocal cosecant. But we're looking for secant, so we know our answer is negative. Next, for secant, you'd want to think in terms of cosine. Cosine of the reference angle. And that would be square root of 2 over 2, or 1 over square root of 2, depending on which one you'd rather see. In this case, I'd rather see this one because we're going to flip it to get secant, the reciprocal. Flip that and we get square root of 2. And that's how you do it. Find cosecant 4 pi thirds. So first off, 4 pi thirds, 0, 1, 2, 3, 4. This is 4 pi thirds. The reference angle is pi thirds, and the quadrant is 3. Knowing all students take calculus, we know that tangent and its reciprocal cotangent are the only ones positive. So in our case, cosecant will be negative. So we already know our answer is negative. Now for cosecant, you want to think sine of the reference angle, sine pi thirds. And that's square root of 3 over 2. And then do the reciprocal for cosecant. So that would be 2 over square root of 3, which then would be rationalized to get negative 2 square root of 3 over 3 for the most common answer. And the rationalization is no more than multiply by a form of 1, square root of 3 over 3, square root of 3 over square root of 3. And that's how to do the problem. Use a calculator to find the function value to 4 decimal places for cosecant 4.04. First off, notice there's no degree sign, so make sure your calculator is in radian mode to do this problem. Now, you want to think sine, because cosecant is the reciprocal of sine. So first off, you'd want to find sine of 4.04 in radian mode. And I get negative 0.78 dot dot dot. I'm not going to write it all down because I'm not done with it yet. Now to get cosecant, you need to flip this. If you look for your calculator, you might have an x to the negative 1 button, or you might have a 1 over x button, or you can just do 1 divided by, and you might have an answer button. Any of these will flip your answer. When you flip your answer, you'll get cosecant. And when I flip negative 0.78, etc., I get negative 1.278223319. Now they ask for 4 decimal places, so we go to the 4th decimal place, the 2. And this next number will not raise it up, so we round it to 1.2782, and that is our answer. Excellent. Indicate the period and the range of the given function. Y equals 2 secant x plus pi thirds. Well, when you're dealing with secant, you want to think in terms of cosine. So the cosine starts at amplitude. If this were a cosine, it would start at 2. And then it would go down to negative 2. So it would alternate between negative 2 and positive 2. It would look something like this. Now I know it shifts over to the left pi thirds, so it would be more like this. But that's what the cosine would do. Now how is the secant compared? First off, let's see what they want. Indicate the period. All right, the period, if this were cosine, and you can write it as cosine if that helps, but it's a little extra work since you're just thinking it. But to get the period, it would be 2 pi over the coefficient of x. So this is the regular 2 pi period. That's the same for secant. So the period is 2 pi. That's one answer. We also need the range. Now the range, cosine is alternating in between -2 and +2. And again, where we got that from is it's not up or down anything, so it's centered at 0. And the amplitude's 2, so it goes up and down 2 from there. The reciprocal is going to stay outside of these values. So it's going to live down below -2, getting up to -2 once in a while, and above +2. So really this would be your range. And the way the book has this is the y values in absolute value are greater than or equal to 2. That's a nice form. Just tells you the y has to be larger than 2 or maybe equal to. You could also have it in interval notation, -infinity, comma -2, hard bracket, union, hard bracket 2, comma infinity. That would be another common form. But other than what form to write your answer in, we have completed this problem. Graph the function. Y equals cosecant x minus pi fifths. Well, we want to think y equals sine x minus pi fifths. Amplitude is 1. Period is regular 2 pi. Phase shift is right pi fifths. There's no vertical shift. There's no plus outside of this thing. Now I'm going to mark with in red with a little X where this thing would be if it were a sine wave. So normally sine would start at 0, 0, but this one's starting right pi fifths. Wow, and these are pi thirds. This is not a nice scale for this problem, but we'll do the best we can. So about there. The period of 2 pi, after a period of 2 pi, it'll be back there. And halfway in between, it would be also in the middle. And then halfway in between there, about there, would be up 1 and then down 1. So the sign's going to alternate between 1 and -1 because of the amplitude. And there's no vertical shift over here. So it's centered at 0. And then right pi fifths makes it a little bit weird. Normally it would be just a nice thing like that, but it just moves right pi fifths. To extend to the left, basically copying this information down, keeping the same pattern. This is 2 periods of this sine wave. Now, thinking sine, this is not the graph of the cosecant though. Now we get to the cosecant graph, and I'll do this one in black with the blue asymptotes, just for fun. Everywhere that sine was 0, we have one here and here and here and here and here. Cosecant is going to be an asymptote. So we can now sketch multiple asymptotes. We now have a bunch of asymptotes. Everywhere the sine was at an amplitude, here, down here, up here, down here, when it's up at an amplitude, that will be where the cosecant would take off. And down would be where it takes off going down. So the black curves are the cosecants. Part of the cosecants need to be the asymptotes. The little red X's, they're fine if you put them down in there. They just help you get the actual graph that you're after. All right, that's it. graph y equals 5/2 cosecant 3x plus pi thirds. So we'd want to start to think in terms of sine, the reciprocal. And I would factor out the 3, leaving me x plus pi ninths. If you want to double check that when you factor something, just distribute it back in and you should end up back here, which we do. So out of this information we get the amplitude is 5/2. The period is normally 2 pi, but we're dividing by 3 because of the coefficient of x. And the phase shift, this is left pi ninths. This information will allow us to graph where the sine would normally be. Now we are left pi ninths, but we're not up or down anywhere. So this thing is going to oscillate around 0. And it's going to go up pi halves, which is 2.5, and down pi halves. Sine would normally start at 0. This one's going to start, oh, this is really hard to graph. In fact, one thing that's making this hard to graph is our period is only 2 pi thirds. It's less than a pi. And we're in a little bit of trouble because these are pi halves, not pi thirds. And the whole thing alternates. It's complete that small. So what I'm going to do is wow, that was not what I wanted to do. There we go. I'm going to change the scope of this problem. I'm going to get rid of these. I'm going to move pi here, negative pi here. Now it's not that much of a change, so it'll still be a pretty condensed graph, but it will allow us to have a nice 1, 2, 3. These are all pi thirds. Okay, good. Now, our normal graph would start at the origin. This one's starting left pi ninths. So the sine would have gone through there. Now the period is 2 pi thirds, so 2 lines worth to the right. So 1, 2, right here. After a period, it'll be back to 0. And sine halfway between that is also at 0. Halfway in between those spots, it'll be at amplitude. So this one's going to go up and down in that little region. It's going to go up to 5/2, 2.5. And it's going to go down 5/2, 2.5. So we have a graph, the sine would be like this. And since this is so small, maybe we can do a couple more. Let's see, another full period over here, and half of that, and then halfway in between, and in between, etc. All right, now for the cosecant. Cosecant, everywhere sine is 0, and we have them here, 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 here. Cosecant's going to be an amplitude, an asymptote. See if this will graph nice. There we go. So we have lots of asymptotes. Everywhere the sine is up at amplitude, here and here, this is where the graph of cosecant will go up. And everywhere sine is down at amplitude, this is where the cosecant will start going down. So the blue graph is the graph of the cosecant, and getting the red x's where the sine would be is really the key to finding what cosecant is going to be. Okay, I hope that whoever writes your test makes a little bit nicer XY chart for your graph so it doesn't have to be recreated, but if it does, hopefully this shows you some of the reasons why you might do it. For this problem, I'm going to use the key points, the 5 key points technique to find the new points for secant. But I'm going to find the 5 key points when I think through the reciprocal y equals 5/6 cosine. 5/4 x plus pi fifths. Now first off, that is not in standard form because the inside of the cosine is not factored. So we need to start with getting it in standard form by factoring out the 5/4. This will leave us x plus, and when you factor 5/4, you're multiplying by 4/5, and that would give us 4 pi 25ths. Ugly numbers on this problem, but the technique is the same. Let's take a look. Now, for the x and the y values of the key points, for example, the x values, first thing you'll do the multiplication and division. In this case, since we have multiply by 5/4, we're going to do the opposite of that. And you can think divide by 5/4, but it'll be nicer to multiply by 4/5. That'll be the first thing that happens to the x values. And then the second thing, see the plus 4 pi 25ths, that would move us left, so we'd subtract 4 pi 25ths minus 4 pi 25ths. For the y values, also two things will happen. Usually two things happen. Sometimes you don't have the numbers in the right spot to have both of them happen. So the y value, we have this multiplication, and that's going to happen first. And you don't have to multiply by the reciprocal. It's multiply by 5/6. But there's no plus or minus outside here. So we actually don't have a second step to do to the y values. So once we get the key points for cosine, we'll be able to use those to find the key points for secant. They in fact are almost the same. Let me demonstrate. So what are the key points for cosine? They are starting at amplitude, so 0, 1, pi halves, 0, pi, -1, 3 pi halves, 0, and 2 pi, 1. These are the key points. Now, we need to take each x value, like 0. The x value, we need to first multiply by 4/5. 0 times 4/5 is 0. Then we need to subtract 4 pi 25ths. 0 minus 4 pi 25ths is minus 4 pi 25ths. The y value of 1, we need to first multiply by 5/6, and we get 5/6. And that's it, 5/6. Okay. Next, the x value, the next point is pi halves. It needs to go through the times 4/5 and minus 4 pi 25ths as well. I've taken a moment to do all this work on scratch paper. I suggest you do as well. You end up with 6 pi 25ths. And then 0, I can walk this one through. 0 times 5 pi 6 is 0. Okay, next up, pi. I can work this one out. Pi times 4/5 is 4 pi fifths. Minus 4 pi 25ths, common denominator, that'll give you 16 pi 25ths. And -1 times 5/6 is -5/6. Before long, you'll start to notice the pattern. Notice -4 pi 25ths going to 6 pi 25ths going to 16 pi 25ths. Add 10. Add 10. Add 10. The next one will be 26 pi 25ths. And then 0. And 36 pi 25ths. And 5/6. The y values are easy because you multiply by 5/6. So there are 1 times 5/6, 0 times 5/6, -1 times 5/6, 0 times 5/6, and 1 times 5/6. The x values are a little bit harder, but even your calculator if you had to do that. All right, now what this gives us are the key points. I'm going to put x's down for these. Negative 4 pi 25ths and 5/6 is about there. 6 pi 25ths. See which one's nice. 26 pi 25ths is about pi. And there's a couple in between there. So divide that into 2. There and there and there. And again, this is not easy, but that gives you an idea of where these key points are. This would be your cosine. Now what the cosine gives you, because this problem was a secant, everywhere cosine was 0, it's a vertical asymptote. And everywhere cosine was at the bottom is where the secant goes down, and every time cosine was at the top is where the secant goes up. So we don't have a lot of this, but it took so much work just to get this because of the ugly numbers that unless you wanted to rescale this axis and make it in terms of nice 25ths values, and then you'd have a line for each spot you needed to add, this is about as good and as quick as you can make this. All right, let's move on. The graph of y equals cotangent x is shifted a distance of pi 6 to the right, then stretched by a factor of 2, then translated 7 units upward, then reflected in the x-axis. Okay, each one of these changes you should understand. For example, pi 6 to the right will be a minus pi 6 inside. Stretched by a factor of 2 will be a multiply by 2 outside. Translated 7 units upward will be a plus 7 outside. Reflected in the x-axis is change y to negative y. Let's take a look at what these do to the graph. They say find the equation. So y equals cotangent x. First off, 6 to the right, y equals cotangent x minus pi 6ths. Great. Next, so that'd be 1. Here's 1. 2. That would be y equals 2. Cotangent x minus pi 6ths. Okay, the third thing we need to do, 7 units upwards, y equals 2 cotangent x minus pi 6ths plus 7. And finally, the fourth thing, reflected in the x-axis direction, that would be y equals, you put a negative out in front of the whole thing when you do an x reflection. You change the whole function. And the effect of that is then you distribute the negative. When you distribute the negative, your final answer is negative 2 cotangent of x minus pi 6ths minus 7. That completes this graph, this equation of this graph. Find the equations for all vertical asymptotes for the function y equals cosecant 4x plus pi. Well, for cosecant, you want to think in terms of the sine. Now specifically, cosecant has an asymptote when sine equals 0. So we need to find when sine 4x plus pi equals 0. Now, sine of theta equals 0 at k pi, where k is an integer. This comes from the graph. Pi, 2 pi, 3 pi, Sine just keeps going to 0 at all the pi's. So k pi. So we need to find out where 4x plus pi equals k pi. First off, subtracting pi, 4x equals. Now the right side, k pi minus pi. K pi is any kind of pi. Let's say k was 5. Then it would be 5 pi minus pi, which is 4 pi. But 4 pi is just another k pi. So k pi minus pi is still some unknown k pi. Divided by 4. We have x equals k pi fourths. Now x equals k pi fourths, these are all the spots where sine equals 0, which are also all the spots where cosecant has a vertical asymptote. A vertical asymptote, a vertical line has an equation x equals. So this x equals is not only the values where sine equals 0, but they are in fact the vertical asymptotes for cosecant. Great. Find all vertical asymptotes for y equals secant x divided by 3. To do this, you want to first think in terms of cosine. The reciprocal. Cosine of x thirds. Now, secant will have a vertical asymptote when cosine equals 0. Now, cosine theta equals 0 at pi halves plus k pi. If you think of the graph of cosine, it starts at an amplitude. After 2 pi, it's back to the amplitude. Pi in the middle, it's the bottom amplitude. And it's 0 in the spots in between. That would be pi halves and 3 pi halves, etc. And so it's pi halves plus pi is 3 pi halves plus pi, or pi halves plus k pi. We need to figure out where x thirds equals that pi halves plus k pi. So we multiply by 3 to find out. Solve for x. X equals 3 pi halves plus 3 k pi. These are the equations of the asymptotes, the vertical asymptotes for secant. These are also the values where cosine would equal 0. They are one and the same. Excellent.